Hello everyone, welcome to my channel. Today we will begin a new topic, methods of preparation of haloalkanes. This collectively is known as Lucas reagent. When it reacts with HCl in the presence of zinc chloride, it will form RCl. Here this zinc will act as the electron acceptor. What is the role of zinc here? ZnCl2 plus. There is a lone pair on oxygen which will be accepted by the zinc and it will form further. What will happen? There is the HCl. So this will be removed from here. Cl negative will attack on this and it will be removed. And what will be become? This RCl plus ZnOH Cl2 negative. So here what is the role of zinc? This zinc will act as the electron acceptor and it will accept the electron and helps to form alkyl halide. This Lucas reagent also used to distinguish the different types of alcohol. This alcohol may be primary, secondary or tertiary. So it is also used as a distinction test. For example, if we take here a tertiary alcohol, then after putting this Lucas reagent, the turbidity appears immediately. This will show this alcohol is tertiary alcohol. If the turbidity appears after some time, maybe 2 to 3 minutes, then it will be secondary alcohol. And if the turbidity will take too many hours, then it will be primary. Or if turbidity will not appear, then it is primary alcohol. So Lucas reagent is very important. It is used as a distinction test for alcohols. Next is when this alcohol react with PCl3. This is phosphorus halide. Instead of Cl, any halide will be used. It will form alkyl halide along with the evolution of phosphoric acid. Next, when it is react with phosphorus halide again, but this halide is phosphorus pentachloride. Here is phosphorus trichloride. Again alkyl halide will form, but in this case PuCl3 will be eliminated. Next, when alcohol will react with thionyl chloride, this is the best method. When this alcohol react with SOCl2, thionyl chloride, then it will form alkyl halide. Sulfur dioxide and HCl will be evolved. Now, why this method is considered as the best method? See all the reactions. There is certain byproducts in all the reactions, but in this case the byproducts are all gases. So we can easily separate pure alkyl halide from this reaction mixture by just boiling. These both gases will evaporate and the pure alkyl halide we get. Next is alcohol. It reacts with in the presence of red phosphorus with the halogen and it will form alkyl halide. Here this acts is mainly bromine and chlorine. Next is this is mainly for the alkyl bromide. Now in this case NaBr will react with alcohol in the presence of H2SO4 and it will remove NaHSO4 and water with the formation of alkyl bromide. This method is mainly specific for alkyl bromide. So these are all the methods of preparation of haloalkanes from alcohol. Next method is from hydrocarbons. Hydrocarbons are basically those compounds which are made up of carbon and hydrogen only. So there are three categories from alkanes. First we will take alkane. We have taken the smallest alkane, which is methane. Now what will happen in this case? In the presence of light, what will happen? This hydrogen is replaced by this chlorine by the removal of HCl. And here along with it HCl is removed. It can be further reacted with Cl2 in the presence of light and it will form CH2Cl2. One more H is replaced. Now if we further react with Cl2 in the presence of light, it will form CHCl3. The number of halogen will increase along with the decrease in number of hydrogens, because these hydrogens are replaced by chlorine. So further if it will react with Cl2 in the presence of light, it will form CCl4. After this it will not react because here is no hydrogen and carbon have already made its 4 bonds with the chlorine. Now this is the general method. This method is done by the free radical mechanism. Free radical. Next is from alkenes. Similarly, in the presence of from alkenes, when we add HI, from alkenes, when we add HI, what will happen? This double bond will break and on either side hydrogen will attach and on other side iodine will add. Now what will happen? Carbon, hydrogen, hydrogen. On one side hydrogen will add and on the other side iodine will add. Here all the substituents are same. Now this problem is created when the substituents are different. See. Now see, here this carbon is attached to 2 carbon atoms and this carbon is attached to 1 carbon atom. Now the question is arise, on which side this hydrogen will go and on which carbon this iodine will go. This is on the basis of Markovnikov rule. What does Markovnikov say? He says that the iodide means halide group will go on that carbon which is more substituted. This carbon is more substituted because one side is occupied by carbon, all the 3-4 bonds are joined with carbon. So this carbon is more substituted. So what will be the product? CH3, CH3. Here iodine will be added and here hydrogen will be added. So this will be your product. This is according to Markovnikov rule. This is very important rule which says that the halide group goes to that carbon which is more substituted. Now so we can say this as a Markovnikov product. Now with respect to this, there is another rule also, that is anti-Markovnikov rule. Here along with this product, other product will also form, but this product will be major amount. Now if this alkene reacts accordingly to anti-Markovnikov rule, anti means opposite to Markovnikov rule. Markovnikov rule says that halide will attach to more substituted carbon. So according to anti-Markovnikov rule, what will be the concept? The halide will attach to that carbon which is less substituted. So what will be the major product? In this case both products will form, but the major product will be that which is less substituted. This will be its major product and this will be its minor product. If we talk about Markovnikov, this will be the major and this will be the minor. So this is the preparation of alkyne halide from alkenes. Now come to by electrophilic substitution. This will take place in benzene, or it can say on alkene also, plus Cl2 In the presence of FeCl3, FeCl2, anything you can use, what will happen? Basically, what will happen here? This is Cl and this is Cl. This double bond will attach on this chlorine and it will go up. As these are both electronegative, so one is supposed to be more electronegative and has a partial negative sign. So other will have partial positive sign, and this positive sign chlorine will be attacked by the double bond because benzene itself is an electron rich species. So it will attack on chlorine and this chlorine will be removed. So by this the chlorine will be attached here and here you will get the positive charge. Now what will happen? This Cl negative will left. What it will do? This Cl negative will attack on this hydrogen and remove it by the elimination of HCl, and this double bond will shift here. So by the electrophilic substitution, this is electrophile because it is positive charge species. So it is electrophile. It will substitute in place of hydrogen. So it is called electrophilic substitution reaction. These are the methods of preparation from hydrocarbons. Now we will discuss some more methods. Next method of preparation is from benzene diazonium salt. Before this, we have to understand how this benzene diazonium salt will be formed. We will take aniline. And it reacts with NaNO2 along with HX at 273 to 278 Kelvin temperature. Then it will form this is benzene diazonium chloride. Further, this benzene diazonium salt forms number of products. It depends on reagent only. First, if we use copper salt as a product, CuX2, here X is chlorine or bromine, then it will convert to chlorobenzene or bromobenzene. It depends on the reagent. So this reaction is called Sandmeyer reaction. But this Sandmeyer reaction will not form iodobenzene or fluorobenzene. Next, second method is if we use copper powder in benzene diazonium salt along with HCl, then it will form chlorobenzene. Along with HBr, then it will form bromobenzene. This reaction is called Getterman reaction. Getterman reaction. These name reactions are quite important because it can be asked by name also. Next is if we want to form iodobenzene, we will react potassium iodide with benzene diazonium salt, and in last we react aqueous metal salt with benzene diazonium chloride. It will form fluorobenzene. It will take place in number of steps. Let us consider in steps. What will happen? First, this metal will remove this Cl from here and it will convert it into N2 positive, BF4 negative. Further, what will happen? On strong heating, this BF3 will remove. On heating, this BF4 negative will remove. On heating, this BF4 negative will remove. N2 positive plus BF4 negative. This N2 is unstable along with the positive sign, so it will be removed from here. So minus N2, what will be become? Here the positive charge. But we also know there is the BF4 negative in the reaction mixture. This will attack on it and it will lead to the formation of fluorobenzene along with BF3. This reaction is called Bals-Schimann reaction. Bals-Schimann reaction. This formation of fluorobenzene from benzene diazonium salt, this reaction is called Bals-Schimann reaction. Now, next come to halogen exchange. It involves two reactions, Finkelstein reaction and Swart reaction. In Finkelstein reaction, what will happen? RCl plus NaI. Here you can take X, it may be chlorine, bromine. So we will take X. NaI in the presence of acetone. This is the reagent for Finkelstein reaction. And what it will form? This just simple thing, this halogen will remove from here and join with this alkyl halide, and this halogen will come here. What will become? Ri alkyl iodide plus NaX. This is a Finkelstein reaction for the formation of alkyl iodide. Next is Schwarz reaction. Similarly, it also involves the exchange of halogen, but it leads to the formation of alkyl fluoride. You can use SbF3, SbF5, Ag2F2. Out of these, any reagent can be used. So this fluorine will attach with this R group, alkyl group, and this X will come here. And what will happen? RF alkyl fluoride plus AgX will be the product. This reaction is called Schwarz reaction. After this, we will discuss two more methods, Hunziker reaction and from the side chain reaction. Next method is Hunziker reaction. In this case, we will take a carboxylate salt of silver, O negative, Ag positive. This R will be aromatic. And in the presence of X2, CCl4 reflux, instead of X you can take Br2 negative. Here free radical reaction will take place. This bond will break and CCl4 reflux. Here what will happen? RC double bond O, it will lose one electron, minus one electron from this negative. It will become O radical. After this, it will follow the free radical mechanism. This bond will break and its radical will come here and here. It will become C double bond O, this is CO2 plus R radical. We know that there is the bromine molecule in the reaction. This bond will break and this radical will combine with bromine. It will form RBr plus this Br radical is in the reaction. It leads to the formation of aryl halide. And this is known as Hunziker reaction. Next is from side chain halogenation. This is also for the aromatic compound. If there is this alkyl group, if this alkyl group acts as a side chain, then in the presence of light, what will happen? In the presence of light, this Cl bond will break and it leads to the formation of radicals, and this bond will also break and leads to the formation of radical, and this one Cl will combine with hydrogen and another Cl will combine with CH2. Then it leads to the formation of CH2Cl plus HCl. This reaction involves the halogenation reaction, but that takes place at the side chain present on the aromatic ring. This is all about the methods of preparation of haloalkanes as well as haloarenes. That's all for today. Thank you and have a nice day.